Did we do the break already? Oh, shit. Okay. You guys are so pathetic. A difficulty with momentum. Before we get into it, okay, a difficulty with momentum problems. Okay, mass walks into a bar. Here we go. Mass walks. You have to write that into bar. All right, so we got a mass here, M1, we got a bar like that, M2, right? So they're going to crash into each other. And the mass 1 is going at VI, okay? And I keep talking about them bouncing off of each other, and we have two equations, and we're thinking about the forces. But then, let's see, the final part of this will be, what does mass 1 do? It might bounce back, V1F, and the bar might go this way, V2F. V1, I guess I'll say 1 initial, only this one was moving at the start. But really, this one could have been moving at the start. It could have been coming at it, V2I. So what if you wanted to solve in detail and solve for those two velocities, the final velocities, just with momentum conservation? We've been doing lots of problems. We've been giving you more information. We've been telling you things like the masses and how fast things were going. What if we didn't tell you how fast things are going? What if we just had two masses and we crashed them into each other? I forgot to get them. What if we had two cars and they just crash into each other? If we have both initial velocities and both masses, we should be able to know what's going to happen. The universe is deterministic. It's not really, but let's pretend that it is. Okay? So we should be able to get it. So let's look at the math. Well, we have one equation that we could use. And that is, for an isolated system, we have the momentum conservation. If we have m1 times v1i plus m2 times v2i, we just need m1 times v1f, and we need m2 times v2f. Okay? So what we have is what I like to call two equations and two unknowns, T2, T-E-T-U, two equations, two unknowns, all right? But now we have something much worse. We have one equation, and we have two unknowns. Oh, no. We have what do I call this? We have T-ow, two equations, one unknown. You say, T-ow, oh, what are we going to do? So what we're going to do, we have two equations. Oh, that's why it didn't make sense. Yeah, what do we have? Let's make up the new word. Yeah, well, this would also be bad because it might be overdetermined. We have one equations, two unknowns, OE2. That's not good. This has been wrong for years. Oh, well. Okay, so what should we do? What do? We could use energy. So if you have the third edition of the book, it does energy first. No, wait. If you have the fourth edition of the book, it does energy first before momentum. And the third edition did momentum before energy. That's why they did a new edition, is to justify a new edition, because they just switched those two. But that's not till next week. Right? So is there any other solution to this problem? Or are we just done? There's a solution. And the solution is we do a special kind of equation where the masses stick together. Right? If the masses stick together, how many final velocities are there? Just one. And I think I have this right. We have one equation, one unknown, which is ouiao, which is French for I can do it. Let's see. Check it on Google Translate. It really, that is what that means.